Autodesk Simulation Mechanical has a design optimization utility that automates the process of determining your optimal design dimensions. This utility is applicable to all structures containing beam or plate type elements. This example is a small suspension bridge that supports a load of 1.5 US tons or 3,000 pounds in addition to its own weight. The bridge frame and suspension consists of Schedule 80 pipe, rectangular steel bar, and wire rope, all represented by beam elements. The deck is aluminum alloy represented by plate elements. You define the plate thickness and beam cross-sectional properties in the FEA editor within the Element Definition dialog box. For plates, activate the Design Variable checkbox to optimize the thickness. For beam elements, choose the layer containing the beams that you wish to optimize and then go to the Cross-Section Libraries dialog box. You can choose from among the built-in libraries of standard sections or specify a user-defined section. Here we see the initial dimensions of a rectangular section. To optimize a dimension, right-click on it and set it as a design variable. Run an analysis to determine the results based on the initial plate and beam dimensions. You will also need to know the initial volume of the assembly. Use the Weight and Center of Gravity tool to determine that information. We're ready to click the Optimization command. The Design Variable tab lists the dimensions to be optimized. For each, you can specify a lower and upper limit, which permits any value in between the limits, or activate the Discrete option to define specific allowable values, limiting the possibilities to standard stock products. For a discrete variable, click the Current Value field and then the Ellipses button. In the dialog box that appears, define the discrete values. In the Performance tab, specify the objective, in this case to minimize the assembly volume and therefore its weight. Also, specify the design constraints, such as upper stress and displacement limits. Specify the part or parts to which each constraint applies and the current value for each objective and constraint based on the initial values analyzed. Run the design optimization from the Analysis pull-down menu. A log records the iterative process of determining the optimal model parameters. The current values and the changes in the results are listed along with indications of whether or not each constraint has been violated. You can view various graphs, such as the optimization history plot shown here. This graph shows the maximum stress in the deck plate for each iteration. You can also run design studies and view plots indicating design sensitivity, that is, the relative extent to which each design variable affects the objective or various constraints. For example, here we see that the plate thickness, variable 3, has the greatest impact on the maximum displacement result. Finally, a new FEA model is automatically created in which the dimensions are set to the optimized design parameters. Review this model to confirm that all results are within the allowable ranges.